All right, so let's go ahead and get started. Today we'll start with 12.2, Permutations and Combinations. So they begin this section talking about factorials. Whenever you see an exclamation point in mathematics, that means factorial. That means you start off with that number and you count down by ones all the way down to 1. And you multiply those numbers together. So if you had 100 factorial, that would be 100 times 99 times 98 times 97 times 96, all the way down to 1. 1 factorial is 1, and 0 factorial is also equal to 1. All right, so a small example of that, 4 factorial is 4 times 3 times 2 times 1, which is 24. All right. So let me erase this so we can walk through it. So if we had 8 factorial over 5 factorial, I'll show you the long way of dealing with it, then we'll look at the short way. So if I wanted to expand it out, 8 factorial is 8 times 7, 6, 5, 4, 3, 2, 1. 5 factorial down bottom is 5, 4, 3, 2, 1. So when it comes to fractions and the way we can reduce, we know 5 over 5 will cancel, 4 over 4 will cancel, 3, 2, and 1 will cancel because they all have that in common with the top and bottom. What you'll be left with is 8 times 7 times 6, and that's 336. All right, so that's a long way of dealing with it because once again, if you had 100 factorial, let's say over 50 factorial, what you don't want to have to do is write out 100 numbers, then write out 50 numbers to realize what cancels out. So what we do is recognize here that we have 5, 4, 3, 2, 1, and 5, 4, 3, 2, 1, which is 5 factorial in both cases. So the short way of dealing with it is just recognizing that if there's 5 factorial that's in 8 factorial. So you count down to the 5 and stop right there, and then that cancels, and that leaves you with just 876. So once again, instead of expanding it out and writing out every number, you just recognize that the smaller number is in the larger number as far as factorial is concerned, and cancel that all the way down to 1, and you'll still get the same product. All right. So at 100 factorial over 98 factorial, I wouldn't count 100 all the way down to 1. I would just go to 98 and stop because that's what's in the denominator. Cancel out that 98 factorial, and I'm left with 100 times 99, which is 9900. All right, questions? All right, so the next one, if I have 5 factorial minus 3 factorial, what I would do is expand out. What I cannot do is do 5 factorial minus 3 factorial, which is 2 factorial. So it doesn't work that way. I have to expand out 5 factorial, which is 5, 4, 3, 2, 1. Expand out 3 factorial, which is 3 times 2, 1. 5, 4, 3, 2, 1 multiplied is 120. 3, 2, 1 multiplied is 6. And then 120 minus 6 is 114. All right, so actually getting into permutations. This is an arrangement of items in which the order matters. So here we have our permutation formula. Permutation of n things taking r at a time. NPR is equal to n factorial over n minus r factorial. So what we mean by n things taking r at a time. So let's say if I have 30 students, I want to know how many different ways can I create a group of 5 to take to a conference. So how many different ways can I do 5 out of the 30? So a permutation of 30 students taking 5 at a time. How many ways can I take 5 out of the 30? So your n will always be the larger number. You know how many different ways can you take r out of the n. So it's n factorial over n minus r factorial. So we'll go through the formula a couple of times. But if you have a scientific calculator, that function should be in your calculator. And if you need any help with that, always feel free to email me and try to figure out how to work your calculator. Should be able to do so. All right, let's look at the first one. Now remember with permutation, the order matters. All right, so we have a university tennis team consists of 6 players who are ranked from 1 through 6. If a coach has up to 10 players from which to choose, how many different ranked teams can the coach select? Give you a chance to write that down. All right, so university tennis team consists of 6 players who are ranked 1 through 6. If a coach has up to 10 players from which to choose, how many different ranked teams can the coach select? So he has 10 players that he's going to be choosing from, and he has to choose 6 out of the 10, and they are ranked 1 through 6, so the order matters. So this is no, we'll be using the permutation. So remember, your larger number is n. So n is equal to 10, r is equal to 6. So that's 10p6, 10 factorial over 10 minus 6 factorial. Do what's in your parentheses. So that's 10 minus 6, which is 4. So you have 10 factorial over 4 factorial. Remember, we count down to 4 and stop right there. That leaves us with 10 times 9, 8, 7, 6, 5. And multiply those together. You have 151,200 different ways you can create a team. All right. So next one, in 2015, 18 horses were entered in the Kentucky Derby. How many different finishes of first through fourth place were possible? All right, so we have 18 horses to choose from. And we're talking about ranked first through fourth place. So that lets us know the order matters. So N will be equal to 18, R will be equal to 4. It's 18P4. So plugging that into the formula, that's 18 factorial over 18 minus 4 factorial. 18 factorial over 14 factorial. And that will calculate out to 73,440. All right, questions? All right. Next one, 5 women and 4 men are to be seated in a row of 9 chairs. How many different seating arrangements are possible if the first one we say there are no restrictions on seating arrangements? Give me a chance to write it and we'll look. All right, so we're going to look at how many different ways we can seat them if there are no restrictions on the seating arrangements. So just walking through this, make sure you're okay with what's going on. First thing I would do is set up my chairs. I have 9 chairs, so I also have 9 boxes for each chair that I have, and there are 9 people to choose from. So in each box, I will write which number or how many options I have for my people. So in the first box, I have 9 people. So I write down 9. After that first person sits down, I have 8 people. After this person sits down, 7 people. Then 6, 5, 4, 3, 2, and 1. So at the time, I always write down how many choices I have at each seat to choose as far as people to sit down. And then multiply those together, that gives me 362,880. All right, any questions? All right, the next one, you want to sit the women together and the men together. So if I want to sit the women together, there are 5 women and there are 4 men. So I still set up my 9 seats, but the first 5 seats are women, and the next 4 seats are the men. And once again, in my boxes, I put my choices. How many choices do I have for each seat? So in the first box for the women, I go 5. When she sits down, 4, 3, 2, and then 1. And for the men, I start off with 4. And then after he's sat down, then it goes 3, 2, and 1. Multiply those together, I get 2880. And then we have to consider the men sitting first, and then the women sitting second. So it's the same numbers, but just set up in reverse. In other words, I have 4, 3, 2, 1 as my first box of information or first set of seats, and then 5, 4, 3, 2, 1 for my second set of seats to represent the women. Still should get the same number, but I'm just showing you what we're doing and how we getting that number. All right. So then you add them together, and that'll give us 5760 as our final answer. All right. Questions? All right. So combination is a collection of objects in which the order does not matter. When permutations, the order matter. Combinations, the order does not matter. So same thought process as far as N and R are concerned, though. You have combination of N things taking R at a time. N is still going to be my greater number And I want to know how many different ways can I choose R out of N. And the order does not matter. All right, so an emergency room at a hospital has 11 nurse staff. Each night, a team of 5 nurses is on duty. How many different ways can a team of 5 nurses be chosen? All right, so this has nothing to do with order or ranking, first, second, third place, or anything like that. So that's how we know we're dealing with combinations. Just want to know how many different ways can I choose 5 nurses out of the 11 nurses. So plug it in accordingly, or use it in your calculator right, or correctly. We got n is equal to 11, r is equal to 5, so that's 11c5. We have 11 factorial over 11 minus 5 factorial times 5 factorial. 11 minus 5 is at 6. And I put those parentheses there because depending on your calculator, you may have to use those parentheses to keep the 6 factorial and the 5 factorial in your denominator. And that'll be 462. Questions? Any questions? All right, so the next one, a committee of 5 is just from 5 mathematicians and 6 economists. How many different committees are possible if the committee must include 2 mathematicians and 6 economists? All right, so when we look at what we have here, we're going to choose a committee of 5 from the 5 mathematicians and the 6 economists. Now, out of these 11 people, 2 will come from the mathematicians, and then 3 will come out of the economists. So those 2 mathematicians cannot come out of the 6 economists. So what we'll do is we'll find the combinations of each one of them individually. I need 2 to come out of that 5. So that's 5C2. Throw that in the calculator, you'll get 10. And then I need 3 to come out of that 6. So 6C3 will be 20. Once you find those values, multiply those together, and you'll get 200. right, any questions before we look at 12.3? All right, probability and odds. Probability is the likelihood of the occurrence of a particular event. It is between 0 and 1 inclusive. That means it can be 0, it can be 1. Let me see this. All right, so finding the probability. This is P of E. That just means the probability of event E. And that's N of E, N of S. So that's just how you would say that. And the top number, the way you would calculate your probability or find your probability is that you would calculate or find out the number of outcomes in your event, then find out the number of outcomes in your sample space, and number of outcomes event over your sample space would be your probability. All right, so a single die is rolled. Probability of rolling a 3. So we talked about in 12.1 sample space in your event, and what an experiment is. So an experiment is this die rolling a single die. So and it's an occurrence in which the outcome is uncertain. So that's an experiment. Your sample space is the total number of outcomes that can occur from your experiment. So we want to find the sample space first. It's always easier to find the sample space first, establish all of the possible outcomes. So when we look at a single die being rolled, you know, you got 1, 2, 3, 4, and then I could have wrote that one better. So we have 1 through 6 as our sample space. So that means the number of outcomes in my sample space is 6. And also don't confuse this 6 and this 6. If that was 1, 2, 3, 4, 5 triangle, in other words, I have 5 numbers and then a triangle on one side of this, the number of outcomes in my sample space would still be 6. So those two sixes have nothing to do with each other. This just represents the number of outcomes in the sample space. All right. So now we explore the number of outcomes in our event. The event is rolling a 3. So the number of outcomes in the event is just 1. So the probability of rolling a 3 is just 1 out of 6. Questions? Any questions? All right. So what's the probability of rolling an even number? We're in the same problem, so we don't have to reestablish our sample space. We can just go to the event. Our event is 2, 4, 6. Those are the only even numbers in our sample space. So the number of outcomes in our event is 3. So the probability of rolling an even number is 3 over 6, which is 1/2. One more with a single die. All right, so we want to roll a number greater than 4. All the numbers that are greater than 4 are 5 and 6. So there are 2 numbers that fit that description. So the probability of rolling a number greater than 4 is 2 over 6, which is 1/3. All right, questions before we go to another problem? All right, so a fair coin is tossed 3 times. What is the probability that 2 heads and 1 tail are tossed? So once again, we wanted to establish our sample space. So we need to figure out how many different ways or how many combinations will we get out of the coin being tossed 3 different times. So we can set up our tree. We've done something like this before. The first time, second time, and third time it's tossed. Start off with landing tails first. Tails and heads. Do the same thing for heads. All right, so we have our 8 possible outcomes. Tails, 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 head, tails, heads, tails, tails, heads, 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 tails, tails, heads, tails, heads. A little bit better. Heads, heads, tails, and heads, heads, heads. So we have 8 possible outcomes. All right. So when it comes to our event was 2 heads and 1 tail. So that happens here. In fact, I'll just box in. Having 3 different spots, 2 heads and 1 tail. So the number of our event is 3. So the probability of our event occurring is going to be 3 over 8. All right. Questions. All right, so we have 2 fair dice are tossed. What is the probability that the sum of the pips on the upward faces of the 2 dice equals 8? So before we had 1 die was tossed. Now we have 2 that are being tossed, 2 dice. So the way we would find our sample space and the way we should be looking at it, we have die 1, die 2. So we want to know all the combinations of when this is 1. And I'll just write it like this. 1 and 1, 1, 2, 1, 3, and so on. And then when die 1 turn, it's 2. And then 1, 2, 3, and so on, all the way down to 6. And so the short way of doing this, you want to find the number of your sample space. You don't want to have to list them all out because it's easy to miss one and there's a lot to list out. You would take the number of options in die 1, which is 6, multiply it times the number of options in die 2, which is 6. So that means we have 36 possible outcomes. So that goes back to our counting principle. So if I had a die that was 6 faces and then die 2 was eight faces, then I would do 6 times 8. You know, so you just multiply those numbers together to figure out what your possible outcomes are, or the number of possible outcomes. So the event is how do I want to write it? So we want to know when the 2 dice are equal to 8. So there's no such thing as 1 plus 7. So die 1 being equal to 1, die 2 being equal to 7 doesn't work for us because they're not 7 faces. So we had to start off with 2 and 6, 3 and 5. Then we know 4 and 4. Now die 1 being 3 and die 2 being 5 is different from die 1 being 5 and die 2 being 3. So that's a different combination. And then 6 and 2. So as far as your event goes, we have 5 possible outcomes. All right, so that means the probability of an event occurring would be 5 over 36. So one more type of thing in this section and we'll be done with it. All right, so calculating odds. If you want to calculate the odds in favor of your event E, that's the number of favorable outcomes over the number of unfavorable outcomes. And the odds against E is the number of unfavorable outcomes over the number of favorable outcomes. All right, so if a pair of dice is rolled once, what are the odds in favor of rolling a sum of 7? So we already know from dealing with a dice before that the sample space, total number of outcomes, is 36. All right. So how many different ways can we get a 7? So you're talking about 1, 6, 2, 5, 3, 4, 4, 3, 5, 2, and then 6 and 1. So all those add up to give us 7. So you get 6 different ways that we can get a 7. So this 6 represents the number of favorable outcomes. If I want to find the number of unfavorable outcomes, I would take my sample space and minus that 6, which would be 30. We want to know the odds in favor. So what we'll do is take the number of favorable outcomes and place it over the number of unfavorable outcomes. That'd be 6 over 30, which reduces to 1 over 5. So odds in favor of rolling a 7 is 1 to 5. Any questions? Any questions? Before we look at this last example. Any questions? All right, so the relationship between odds and probability. Suppose E is an event in the sample space and the odds in favor are A over B. Then you can calculate the probability of your event by doing A over A plus B. Suppose E is an event in the sample space, then the odds in favor are the probability over 1 minus the probability of E. So we'll do this last example, emphasizing that, and we'll be good to go. All right, so in 2010, the race horse Drosselmeyer won the Belmont Stakes, beating the favorite Icebox. The odds against Drosselmeyer winning were 12 to 1. What was the probability of Drosselmeyer winning the race? All right, so the key phrase here that we have to be aware of is that this was odds against. So the odds against Drosselmeyer winning was 12 to 1. So go back to our relationship. This relationship sets us up to use odds in favor. All right. So if we go back to the notes, the difference between odds against and odds in favor, and all you're doing is flipping your numbers. So odds in favor, favorable outcomes over unfavorable. Odds against is unfavorable over favorable. So let's go back to what we have here. We got odds against is 12 to 1. So it means odds in favor is 1 to 12. All right. So the reason why that's important because that establishes what A and what B is. A is equal to 1 and B is equal to 12. You know, if we were using odds against wrong, then we would have the wrong number set up. So going back to our relationship, odds in favor, the way I'll find the probability, it would be A over A plus B. So that'd be A, which is 1 over 1 plus 12. So it was a 1 out of 13 chance of Drosselmeyer winning. All right. Questions? Questions? Any concerns? So, as always, try the stuff out. See if you get stuck with anything. And if you have any questions, feel free to email me. If not, bring them up next class and we will knock it out. So if you're good, I'm good. If you have any questions, feel free to ask. If not, I will see you on next class. All right, have a good one.